there, you're welcome to physics class. Today, we are looking at physics for beginners. If you are taking physics course for the first time, the first thing I need to tell you is that you are welcome to the calculational aspect of science, or you are welcome to the mathematics of science, because physics is the pure maths of science. Now, because physics talks about calculation, well, physics is a science that studies matter, the measurement of matter, giving it a specific quantification. It studies matter and the measurement aspect of matter, giving it a specific quantification. Now, if you want to study physics, you must remove the phobia for calculation from your heart. You must keep telling yourself that physics is easy. In fact, you must keep telling yourself that calculation is easy. You need to understand the basics. The basics is this: physics is a science that studies the measurement of matter, giving it an accuracy or an accurate prescription of the unit of that matter. I take it again. Or you can say physics is a science that studies matter, the measurement of matter, giving it an accurate unit of measurement. Now, you can have other definitions from other textbooks and other writers. But just know that if you say, I want to ask a question, what is the temperature of your body? For instance, will you say that the temperature of my body is 10? That does not make sense. But when I say the temperature of my body is 37 degrees Celsius, it is the degree Celsius that makes the statement to have meaning to us. If I say, what is the distance from the school to your house? I just come out and you say 10 meters. You say 10 meters, all right, 10 meters. You see, it is the meter that gives the meaning of what you are describing. That is why physics is there. Now, the meter gives you that he's talking about distance. Are you with me? Now, maybe you want to go and buy rice in the market, because everybody likes rice. I do. I hope you do too. You want to buy rice in the market, and then you go to the market and you say, give me rice. You listen to the person that is selling, he or she will ask, what quantity, how much? You say 1 bag, 10 bag, 20 bag, or whatever you want to buy. What I'm saying is that physics quantifies matter. Physics measures and quantifies matter. Physics measures and quantifies matter. A science that measures and quantifies matter. This is physics for beginners. So with these illustrations I've made, I'm giving you a question. I want to ask you, what is the weight of your body? What is the weight of your body? And then if you have climbed on a weight before, you will say, well, the weight of my body is 55 kg. Why are you putting kg? Because you are talking about weight. Are you with me now? You are talking about weight. Meanwhile, we have what we call fundamental quantities and derived quantities. We also have what we call fundamental units and derived units. I'm going to make it very brief. Now, for fundamental quantities, you will say these are primary quantities, which is independent of other quantities. The fundamental quantities, and units. Okay? Now, when you hear me use the word quantity, now, physics, when they say quantity, physical quantity, they are talking about distance, they are talking about mass, they are talking about weight, they are talking about temperature, they are talking about all these stuffs. Now, those are called the physical quantities. Now, in the physical quantities, we have fundamental quantities, and then we have the derived quantities. We have fundamental quantities, and then we have also derived quantities and units. Which whatever it is, fundamental quantities quantities, derived quantities is still talking about quantities. Now, if you have fundamental quantities, I take it again that they are the basic quantities or the primary quantities which is independent, they are on their own, independent of other quantities. And then we have derived quantities and units. Meanwhile, if you want to define the unit, just remove the word quantity. Fundamental quantities are basic quantities that are independent of other quantities. Remove. That means you say quantity, remove it. Put unit in there. That means fundamental units, they are basic units that are independent of other units. You see that? Fundamental units, they are basic units that are independent of other units. Now, we are talking about fundamental quantities now and their units. Now, we are going to have a board. Let's use a big board. And then we have these quantities on this side, fundamental quantities. Let me skew for it. We have measurements. Okay? And then we have the units. Alright? In some textbook, this is called a measurement, well, and this is called abbreviation. Whatever you call it is still correct. Unit or abbreviation for the unit of measurement. Alright? So we have the first one to be mass. We have the next one to be length. We have the next one to be time. We have the next one to be temperature. We have the next one to be electricity. We have the next one to be amount of substance. We have the next one to be luminous intensity. Okay, let me put it here. This is luminous intensity. Now, in your secondary school, most of the textbooks do not cover luminous intensity, or it's part of the fundamental quantity. Now, the unit of mass, let me ask you the question. What's the unit of mass? If I want to measure mass, what would I use to measure mass? Of course, mass is measured in kg. Mass is measured in kilogram. Okay? Now, the unit is still kilogram, kg. Let's write it. Kilogram. So, and the unit is what? Kg. What is the unit for length? Well, length is measured in meter. Alright? And then the abbreviation of the unit is M. Then we have time. Time is measured in seconds. And then the abbreviation is seconds. Alright? We have temperature. Temperature is measured in Kelvin. And then the abbreviation is K. We have electricity. This is measured in ampere. And then the abbreviation is A. Then we have amount of substance. This is measured in mole. The abbreviation is mole. We have luminous intensity. This is measured in candela. And the amount, the unit is CD. Now, this is called, these 7 quantities are called the fundamental quantities. Meanwhile, we have the fundamental of the fundamental quantities, which is the mass, the length, and the time. This is the fundamental of the fundamental quantities. Now, in the derived quantities, we are going to use these fundamental quantities to find, when we use them in calculation, you are going to use the fundamental quantities, you are going to calculate with them to find the derived quantities. Now, what do we mean by derived quantities? Can you give it to me again? You can tell me. It says these are, okay, I've not told you, let me tell you now. So derived quantities, these are quantities that are dependent on the fundamental quantities. Units also. These are units that are dependent on the fundamental units. I take it again. Derived quantities are quantities that are dependent on the fundamental quantities. Derived units are units that are also dependent on the fundamental units. You are going to see what we're going to do now. Watch. Just look at the ball. Keep looking at the ball. Stay with me. Stay with me. Just stay with me. Stay with me. Don't be afraid. This is physics for beginners. And then these are the things you need to know. Okay? Now, stay with me. Stay with me. Now, I have derived quantities. I'm going to manage our board because there's a lot of them. A lot of them. We have area, we have volume, we have density, we have velocity, we have acceleration, we have momentum, we have impulse, we have force, we have impulse, we have work done, we have failure, okay. Now, let's energy. We have energy. All right. So we also have frequency. All right. Now, if we remember any other one, we'll put them there. Now, we're going to look at the measurements of these quantities. How do we measure these quantities? Now, how we're going to measure the quantities is this. Now, we have that the area is measured, the area, which is A, is length times breadth. Now, if area is length times breadth, that means that we have meter times by meter. And then this is indices. In indices, you know that x A times by x B is equals to x A plus B. Now, this means that you combine the index power and then we have one is here, one is there. This is meter squared. Now, this is the reason why area is, the unit of area is meter squared. So now here, meter squared. Now, remember it is length times breadth. All right? Now, let's go for the volume. Now, under the volume, we have, let me use it, still have the space. Okay, under the volume, we have that is length times breadth times height. There is 3. Now, this is 3 meters. Meter 1, meter 2, meter 3. Now, these 3 meters that is here, we have it to be 1, 2, 3. Now, this should be meter cube. That is why the volume is in meter cube. And here is length times breadth times height. Are you still with me? Stay with me. Now, we're going to density. Now, how do we find the density? Now, for the density D, density is mass over volume. And then we have the mass is in kg, and volume is in meter cube. Now, your answer will become kg meter cube. Meanwhile, if this division quotient is removed, you are going to have kg meter minus 3. Why? Because of indices. Indices says that XA divided by XB is equals to XA minus B. Now, this means there will be, if this guy should go up, I think I'm not using the right one. Let me give you the right one that it should be. This is not the right indices rule I want to use, but we are still going to use this, okay? Just relax. We have that x minus 1 is the same thing as 1 over x. Now, if this guy should come up, it will carry a minus sign. This is what I want to use. Alright, now we are going to velocity. I know that density is mass over volume, which is kg divided by m cube, meter cube. So this is kg, let's do the division, meter cube. Now this is why this is written in your textbook as kilogram meter cube, as the unit of its measurement. You cannot see that we're using some fundamental quantities, using them in calculation to get the derived quantity. Let's go to velocity. Now, how do we find velocity? Now, the space. Velocity is change in distance over change in time. Change in distance over changing time. Now, I will tell you, if you're a science student and you want to study chemistry, there are some things that you should know, literally. I'm not trying to make it hard for you, but you need to know the formula for velocity. You need to know the formula for acceleration. You need to know the formula for force, for momentum, for work done, for energy, for power. All those things will be handy. You need to have them with you. That means that you need to put effort. Don't try to learn everything once. Trying to learn everything once, there will be a problem. You can take one step at a time. You can take 3 or 4 or 5 quantities, depending on how much you can carry, assimilate them, know their formulas, know how to derive the units, just as what I'm doing here, and then keep it, and the next day you take another one, and the next day you take another one. Before you know it, you'll be able to derive the quantities, or do the calculations to derive the quantities that is known as the right quantities. Now, let's go to the volume. Volume is distance over time, and distance is measured in meter, and time is measured in seconds. If this guy should come up here, still this formula, we have meter per seconds. Meter per second. That is why velocity is distance over time. Actually change. Distance over time, which is meter over second. This is meter per second. Meanwhile, acceleration is change in velocity over change in time. And if that is the case, change in velocity is meter per second. And I'm dividing by seconds. Now, watch what is happening here. Now, we have that x a divided by x b is equals to x a minus b. Now, minus 1 minus 1. Minus 1 minus 1, that is minus 2. So we have meter per second per second. That is why over the acceleration will be changing velocity, changing time, which is meter to the power of 1 divided by seconds. This is meter per second per seconds. That is for acceleration. And you know, I remember Paul. You see, let's put power there after the frequency. We are going to put power. Okay? We are putting power. Alright, now having done that, we move because we still have a lot of them to solve. What is momentum? Now, momentum is mass times velocity. Momentum is mass times velocity, which is kg times by meter per second raised to the power of 1. So this is kg meter per second to the power of 1. And now transfer this into this place, kg meter per second to the power of 1. Why? Because it is mass times velocity. Now, if you see what I'm doing, you'll be able to derive this unit with exactitude of the units because you already have the formulas with you. What I advise you to do, don't be scared. Look at what I'm doing, follow what I'm doing, and then when you finish the class, try to close your book. Try to take the video, watch it again, and then try to close your book. Try to write what you have learned. Okay? And let me also give you a tip of learning. Maybe you are reading, you are studying. Don't be reading and try to write at the same time. Study maybe 1 page, 2 pages, as your strength can carry you. Close the book and try to write down what you will remember from that page. That is an art of recurring. Don't be writing and don't be reading, writing, and that might not help you a lot. If I'm doing that, try this tip of study. Try to study. After studying maybe 1 or 2 pages, don't try to study everything. Study bit by bit. Understand bit by bit. When you study the first 1, 2 page, close the book. You can go to write down what you have learned from what you have studied. Now we are going to Force. Now we are going to Professor Force. Professor Force, the formula for Professor Force. You see, for Professor Force, I'll ask a question. Force. If there is an authority over you, and then a woman, and she's an authority over you, she can force you, she can force you, I don't know what it calls, she can force you to do something. an authority over you, whether you like it or not. You must go to the office and submit to her. If there is an authority and it's a woman, what do you call that woman if you want to address her? Is it not ma? You say ma, and she said come. You say yes ma. So let's say force. Force is ma. You see that? Force is ma, which is mass times acceleration. And mass is kg times acceleration is meter per second per second. If you multiply, this will be kg meter per second per second. So I'm putting it there, kg meter per second per second, because force is mass times acceleration. All right, we're going to impulse. What is impulse? Impulse, we have a space here. Impulse, which is no, impulse, which is should be P. All right. Now, for impulse is just force times time. All right, force times time. And if that is the case, if impulse is force times time, it means that the unit for force is Z naught ma, which is kg meter per second raised to the power of 2. We are multiplying with time. 1 second. Now, watch here. If this is a seconds, and then minus 2 plus 1. Minus 2 plus 1. Remember the indices that say x a times by x b is equals to x a plus b. And if that is the case, it means minus 2 plus 1. This will be equals to kg mass minus 2. Oh, sorry. Yeah, minus 2. Minus 2 plus 1. This is minus 1. So I'm now going to put here equals kg meters minus 1. And meanwhile, before we continue, force, the unit of force generally is Newton. Alright? But if you want to do the unit under calculation with this method, it will be kg meter per second minus 1, which means that this guy is also equivalent to Newton. Give you space. That guy, Newton, or 1 Newton, is equivalent to this kg meter per second minus 2. So this is equivalent because force is measured in Newton. Remember that the force is equal to force times time. Having said that, we move to the next one, which is work done. Right? Work done is force times distance. If work done is force times distance, you can say Newton times by meter. So work done is Newton meter. And you can also use that work done should also be force kg meter per second minus 2 times by meters. Okay, 1 plus 1, that is kg meter raised to the power of 2 and minus 2. Whatever you put this one is still the same thing. What done is Newton meter. Or can also add kg meter raised to the power of 2 and seconds minus 2. So work done is force times distance. Alright? Or displacement, because work done is a vector. Alright? So having done that, we move to the next one, which is prayer. So pray. Maybe there is somebody that is disturbing you, and the person is telling you, do this, do that, come here, do that. And you ask him, because you're a physics student, you say, young man, what is your prayer? And then he also is a physics student. He said, my prayer is your force acting on the area, or acting on my area. So the person is disturbing you, and he said, what is your prayer, young man? And he said, my prayer, he is answering you now. My prayer is your force acting on the area of my disturbance. You know you are disturbing me. So that will become force over area. Prayer. What's your prayer? What's your prayer? I'm asking you now, viewers, what's your prayer? You say, my prayer is the force of how to carry on this calculation in my head over the area, the time taken for me to read up this. This is physics for beginners. You will become a master in physics when you keep practicing and practicing. So this is Newton divided by meter squared. So this becomes Newton meter raised to the power of 2. You can also use that division. Do you understand what I mean? Try that at home, try it at home, try it at home. Do you understand what I mean by using force? That is kg. I won't do that. You need to do that for yourself so that you can enjoy what I'm doing. So we have that pressure is force over area, which is Newton over meter cube, and this is Newton meter to the minus 2. So we have energy. What's energy? Funny enough, energy is still kind of force times distance. Alright? Energy is force times distance. Because when they say energy, and then they say power, these two things, they are correlated but they are not the same thing. Well, power is the rate at which work is done. Energy is the ability to do work. Power is the rate at which work is done. Energy is the ability to do work. So we can now see that energy is force times distance, which is still Newton meter. And then permitted to put energy, which is Newton meter. Then, if it is work done, have I done it? Yeah, I've done it over there. Okay, now, we're looking at the next one, which is frequency. Alright. Now, frequency and period, they are synonymous. I can use period to get frequency, use frequency to get period. Look at what I mean. If you are looking at period, okay, because period is also part of them, you can now make more space and put this period under it. Alright? So if it is period, for instance, period is number of time over number of cycle. Number of time over number of cycle, which means that frequency is measured in seconds. Alright? Frequency is now number of cycle over number of time. And this is measured in hertz. Now, you can put these things over there. So we have power. So what is power? Power is work done over time taken. Because power is the rate at which work is done. Work over time taken. And if this is work done over time taken, what's the unit for work done over there? Let's use that Newton meter. What is the time? The time is seconds. So the unit for work done is Newton meter seconds minus 1. So we can fix that over here for this power frequency. For this one, we can also fix the period in the table. So this is physics for beginners, and this is where we'll stop for today. In our other series, we are still continuing the series for physics for beginners. This is the first series. The subsequent series will be uploaded, and you wouldn't want to miss it. And then, this is all we've got for you. If you have watched this video to this point, thank you very much for watching. Remember, always speak to yourself. Calculation is easy. If you have been afraid of calculation, or you have a phobia for calculation, first thing to do is to speak to yourself. Tell yourself that calculation is easy. Tell yourself that math is easy. Keep speaking to yourself. Keep saying positive. Refuse to confess negative. Haven't done that, then pick up the notes, pick up the textbook, read again, ask questions if you can to your teacher, to your fellow students around you. You will become a master as you learn. Study smart, you will get the best. Thank you.